It's easy, right? On YouTube, like you can just open it whenever you want. So again, the slope is 2. The formula for slope is rise over run. Yeah, first we're just trying to graph this. So if you notice, what's the denominator of 2?
1.
1, right? There we go. So that means the rise is 2 and the run is 1, okay? So what does this mean? This means from the y-intercept, from this point 3, you want to rise 2 units. That means you want to go 2 units up, and then you want to go 1 unit to the right. Run means to the right, so you go 1 unit to the right, and there you go. That's your next point at 1, 5. And to graph any linear function, you just need 2 points. The first one is going to be the y-intercept, and the next one you do it this way, and you join the dots, and that's the sketch of 2x plus 3. Okay. And we can also talk about the domain and range of this function.
Oh yeah, I forgot about that, to be honest.
All right, domain is the possible x values the function can take. And by the way, this is a function, okay? Linear is a function. How do you know it's a function? It passes the vertical line test, you see? If you draw a vertical line, it's only going to intersect the graph once. So that's how we know it's a function. Whereas something like this, you see something like this, if you were to draw a vertical line here, it's going to cross the graph twice. This is not a function.
Okay, so it passes vertical line once.
Yeah, exactly. Vertical line test is when it passes the graph once. And that's how you know if something is a function.
Okay.
Okay, and I write right here, this one, it's gonna it's gonna cross the graph twice. That is not a function, okay? So we know linear is a function. Let's talk about its domain and range. So linear function goes to, if you look at this, it's continuous on the left, it's gonna keep going down, on the right, it's gonna keep going up, right? So what are the possible x values it can take? It can take any x value.
So domain is going to be XER?
Correct. X is an element of all real numbers. Let's look at the range. The range is the exact same thing as the domain for the linear function. Well, the values it can take. Also on the y, it can be anything. It can be negative 10,000, it can be positive million, can be anything. So the range is YER for a linear function. Okay.
So I forget, how do you do it when you have to do like limits, restrictions?
Restrictions would not apply to this function.
Well, no, I don't know this one. I mean, like in general.
You have to kind of know what the graph looks like or be able to sketch it. So let's move on to the next one. Linear is very simple, yeah? Let's look at the next one. Y equals x squared, the quadratic parabola, right? The parent function looks like this, goes through the origin, and it's a u. This is the parent function, okay? Now let's do a more complicated one. Let's do this one, something like x minus 5 squared plus 3. Now, if you notice, this is a quadratic. How do you know it's a quadratic? Because the power is 2. If you open this bracket, you get an x squared somewhere, yeah? So that's how we know this is a quadratic. And quadratic has 3 different forms: the standard form, the factored form, and the vertex form. And when we're talking about domain and range or restrictions, basically the most useful form is the vertex form, which this one is in right now. The vertex form has this format: a x minus h squared plus k, where h and k is the vertex. So compare these two equations. What's the vertex?
The vertex is going to be 0, 0.
No. The vertex here is 0, 0. Compare this equation with this. Look at this. The vertex is at h and k.
Oh, here.
Yeah.
Oh, so the vertex k is 3.
Yeah. And h is?
What's h again? I forgot.
H is right here.
Oh, it's going to be negative 5.
No. See, it's already minus here. So h is positive 5. Okay. 1, 2, 3, 4, 5. So that means our vertex h comma k is at 5 and 3. Yeah. 1, 2, 3. So now let's 1, 2, 3. Now let's sketch this. To sketch this, we can also kind of find the y-intercept. Okay. The y-intercept for any function, not just quadratic, the y-intercept is when x value is 0. Set x to 0. So I'm going to plug a 0 in there. So the y-intercept is going to be 0 minus 5 squared plus 3. And this is negative 5. Negative 5 squared is positive 25 plus 3. So the y-intercept is 28, yeah? This is just to make this more accurate. So the vertex is right here, 5, 3. And is this opening up or down, this quadratic parabola?
It's gonna open up.
It's going to open up, right? So just for convenience, I'm going to say this is 28. So our graph is going to look something like this. It's going to go through the y-intercept. It's going to go through the vertex, and it's going to come right back up like that. Now look at this sketch. The domain for the parent function is XER. X can be anything, similar to the linear function. X is a set of all real numbers. The range for the quadratic is YER, but there's a restriction, right? Y will never be -1 here. If you look at the graph, Y will never be below 0, yeah?
Mm-hmm.
So the restriction for the parent function is that Y has to be strictly greater than or equals to 0.
Greater than or equal to 0.
This is the parent function, okay? For the parent function. Now we can do the same thing for this transform function. Right here, this point is 5, 3. What is the domain for this guy?
The domain is gonna be XER.
Correct. Domain is going to be XER. What about the range?
The range is gonna be everything is it's equal or more than 0. I mean,
Not 0.
3.
3, right? Yeah. Like that. Okay.
Yeah, equal or more than 3. Okay.
Equals to and more than 3. And that's for the transform function. Quadratic, very simple. Let's move on. Actually, let me show you another notation that you can use to write domain and range. Domain and range. So the way that in grade 11 they teach you, this is fine as well. This is called a set notation, okay? So for the quadratic for x squared, the domain is XER. The range is gonna be y is greater than or equals to 0. YER, y is greater than or equals to 0. But there's another method you can write the domain and ranges, and it's called the interval notation. So the one advantage of using this notation system is that you don't have to keep writing YER, XER every time. Okay, and how does this work? Here, look at this. XER, this means X can be anything. And in interval notation, that means X is gonna be everything from -infinity to +infinity.
Mm-hmm.
Now here on the range, y has to be greater than or equals to 0, right? So for the range and interval notation, it's going to be everything from 0 to +infinity. But now 0 is inclusive, right? Y can be 0. That means instead of having a normal bracket, you put a square bracket. Infinities are always exclusive, so you put a rounded bracket. Whereas inclusive, like in this case, y can be 0, you'd put a square bracket in that case.
Mm.
Okay, that's for the parent function, interval notation. And you'll do this in grade 12.
Can we go over like the different like forms, like vertex form and all that?
All right, sure. So for a quadratic, let's go over the different forms. So quadratic has 3 different forms. The first one is called the standard form or general form. That is y equals ax squared plus bx plus c. Okay, an example would be like 3x squared minus 2x plus 9. So what does this form tell you? This form tells you the c value, right? You see this?
Mm-hmm.
That's the y-intercept. And what else is this useful for? The a value exists in every form. That tells you whether it's opening up or down. This one is positive, right? A is positive. Actually, here's some physics notation for you. A equals plus VE. Plus VE means positive, okay?
Mm-hmm.
This is from physics. Actually, this is also applied in real life. Some batteries, if you see the ends, it might say plus VE. So A is positive, that means it's opening upwards, okay? And the general form is when you use the quadratic formula as well. X equals minus B, right? You hear my B is -2, so minus B plus minus B squared minus 4AC over 2A. So you'd use the quadratic formula from the general form.
Wait, what is this for?
This is the quadratic formula to find what X is. For example, they want you to solve for X here, yeah?
Mm-hmm.
Solve this equation for X, you can just use the quadratic formula.
Wait, and quadratic formula gives you x of what? Like, is that the?
Like it solves X's. So what does solving for X here mean? It gives you the X-intercept.
X-intercept. Okay.
So we know this function has a y-intercept of 9, right? And it's opening upwards. We don't know where the vertex is because this form doesn't really give you the vertex, but it could possibly look like this. So if you want to find the x-intercepts, you'd use the quadratic formula.
So it all gives you if it's opening up or down and the y-intercept, but you can also find the x-intercept.
Yes, by using the quadratic formula if it exists. If it exists, then this equation will be solvable. Let's say, for example, in this case, let's say it does not have any y-intercept. It looks like this, right? So if it does not have any y-intercept, you see the square root, you'd get a negative inside that square root. So that means b squared minus 4ac, when you plug in the values, you'll get a negative number in there. And you can't have the negative number in the root, so that means it has no x-intercepts.
Okay. Sounds good. Negative number. Let me just catch this real quick. And I don't know if there's gonna be like questions on it or anything, but like I forget how to like go from after you go over the forms, like how you go from form to form.
Alrighty, so let's talk some more about this. So if you want to go to vertex form from here, I'm going to give you a cheat code. Vertex form, going from general form to vertex form. You know vertex form is h comma k, yeah?
Vertex form is h comma k, yeah.
H is minus b over 2a. You see b here is this, b is minus 2, and the formula for h is minus b over 2a, and the formula for k is just f of h. So what does this mean? This means, for example, this was f of x, right? Y, whatever, that doesn't matter. Let's say this was f of x. Once you find the h value, you plug that in here as x, and that's going to give you the y value of the vertex, which is k. So this is the x value vertex, h, and k is the y value vertex. So let's quickly do that here.
What do you mean? Sorry. What do you mean by k equals f of x?
Yeah, I'll
F
show
of
you.
h.
So let's first find h, right? So here, a is 3, b is minus 2, c is 9, right?
Mhm.
So what does this mean? Now let's use the h. So the x value of the vertex, also called the axis of symmetry, because it cuts the graph in half. Okay, this is going to be the axis of symmetry. It's also called the h value of the vertex is minus b over 2a. So that's going to be minus 2 over 2 times 3. So that's 2 over 6. That's 1 over 3.
Okay.
So now let's find f of h. So you see f of x is this equation. We're going to find f of h. So that means we're finding f of 1 over 3. Okay.
F of 1 over 3.
So this means you see there's x here and here. We're going to replace these x's with 1 over 3. 3 times 1 over 3 squared minus 2 times 1 over 3 plus 9. And now I'm just going to open that on a calculator because that's going to be annoying to do by hand. Divided by 3 squared minus 2 times 1 divided by 3 plus 9. And the y-intercept is 8.67. Or not the y-intercept, sorry, the k value, right? The k value is 8.67. So what does this mean? This means this function has no x-intercepts because we know the y-intercept is 9, yeah? And the vertex is at 1 over 3, 0.33. So it's at 0.33 and 8.67. So right there is the vertex, and it's opening upwards. So this function has no x-intercepts.
So when you found the h is the x.
Yes.
Why is the h x?
H is the x value of the vertex, because in the vertex form, right, the equation is a x minus h plus k, h squared plus k, and here h and k, h is the x value of the vertex, k is the y value of the vertex.
Okay, and like just like to recall, like when it says x minus h, like that number inside is the x value
Positive.
is always the opposite, right?
Yeah, exactly.
So like if it's like -1, it's actually 1.
Yeah. So if you wanted to write this in vertex form, right, we have our h and the k. And again, the a value never changes. Okay, the a value is the one constant between all three forms. So the a value is going to stay as it is. So in the vertex form, this equation is going to become 3. x minus 1/3 whole squared. And then the k value was 8.67. There you go. We've turned this into the vertex form.
8.67 was
The
the
k value, f of h.
we got that after subbing in.
So we first found the h by doing minus b over 2a. Yeah, that was
Mhm.
1/3. And we plugged 1/3 in the equation as x. And that gave us 8.67. That means that's the k value. K is f of h. If this is confusing you, here, look at this. What would f of 1 be?
You just plug in 1 to all those things.
Exactly. So that's what we did. We just plugged what the h is. H was 1/3. We got that from here. We plugged h in there as x, and then we got the k value, which is the y value of the vertex. And this is the same equation in vertex form.
Okay.
And to go from the vertex to the general form, you just FOIL it. You just expand it. So to go back to the general form from any form, you just open the brackets.
And how do you like? So when you have like -1/3 times x, what does it become? Like
If
when
you want
you
to
have
open this bracket,
yeah.
all right, let's do that. We should get the same thing as we had before. So this is 3 times x minus 1/3 times x minus 1/3 plus 8.67, right? Squared means it's the same term, repeat it twice. Okay.
Mhm.
So I'm going to first open this bracket. 3 times x is 3x, and 3 times minus 1/3 is just -1. Like that.
And you didn't go into the other.
No.
Why?
Now I'm going to go into the other one because it's easier if you do one bracket at a time. Now I'm going to open these two brackets, okay? And how do you open them? You see, it's going to be 3x times x minus 3x times 1/3, and then -1 times x and -1 times -1/3. So I'm going to do this step by step. 3x times x is what?
3x squared.
Yeah. What's 3x times -1/3?
-1.
Yes, -1x. Yeah, and then -1 times x is just -1x, and -1 times 1/3 is +1/3 plus 8.67.
And then you just
They're just like terms. So -1x minus 1x becomes -2x, and then +1/3 is 0.33 plus 8.67 is 9. And there we go.
ooh, okay.
So to go back to the general form, you just open the brackets.
And I think there's a trick to this that you don't have to do all this. I think like you can multiply these two terms in the middle and multiply them by 2 or something.
Oh yeah, that's a formula. Yeah, you can do that as well. So that's just that's gonna be something extra, which I use all the time. Actually, it's more efficient. So if you have a minus b squared, okay, when you open the bracket, you get a squared minus 2ab plus b squared.
So here you'd get x squared minus 1/3x.
So x squared minus 2 times a is x, right? So 2 times a is x, and b is 1/3 plus 1/3 squared, which is 1/9.
1/9.
Plus 8.67, and then you open the brackets, you would get 3x squared, and then this 3 is going to cancel out with this 3 in the denominator, so minus 2x plus 3 times 1/9 is 3/9, which is 1/3 plus 8.67. Yeah, basically we got the same thing.
And when you do like when you're doing that trick with the a and the b, the -1/3.
Yeah, just ignore the negative. So this one's negative came over here.
Okay. So then they wouldn't become negative. The one
It
in the
would,
middle.
because of this negative sign on the outside, this term is going to end up becoming negative, but you don't have to do a double negative. You know, if you do a minus here, don't again plug the b as -1/3. Because if you compare this, a minus b whole squared with x minus 1/3 whole squared, right? A is x and b is 1/3, right? B is not -1/3. So that's why this minus sign already accounts for the b being 1/3, -1/3.
And like you wouldn't do 2 times the 1/3, or am I
Oh,
like
you would like, maybe this is confusing you. Here, let's do this, okay?
on like I've been on my bad. I've been on like low sleep with the calculus, so I'm a bit
Oh, yeah,
slow.
here, look at this. 2 times x times 1/3 is what? 2x over 3. Yeah?
Mhm.
Plus 1/9. Okay, like that. Now let's open this bracket. So what does this mean? This means we're going to multiply all 3 terms by a 3. So you get 3 times x squared minus 3 times 2x over 3 plus 3 times 1/9 plus 8.67. Yeah?
3
You
times
see?
1/9. Yeah.
And then this 3 cancels out with this 3. And 3 times 1/9 is just 3/9, which is 1/3. And here you're just left with minus 2x, and here's 3x squared, and then plus 8.67. So there we go. That's a 9.
Okay. I think I'm good with that then.
All right, now let's talk about the other form, okay? If you're good with this, let's talk about the factored form, which gives you the x-intercepts. So the vertex form just gives you the vertex, and it also gives you the direction of opening. Every form gives you the direction of opening, the a value. And it's consistent. See, the a here is 3. That means in the vertex form, it's also going to be 3. And let's say we factored this we can't factor this actually because we saw it before that this one has no x-intercepts. So we can't take this into factored form. Let's talk about the factored form, which gives you, it has this format: a equals a x minus s x minus t, where s and t are x-intercepts. Just like the vertex, you want to flip this, okay? So for example, you had 3 x minus 4 x plus 5. What are the x-intercepts?
1 second. Just writing this down. The intercept.
The x-intercepts.
So the x-intercepts are 5 and 1. Oh, I'm looking at the top. Hold on. 4 and -5, you mean?
Good, yeah, exactly. 4 and -5, right? So if you want to sketch this, we know at 4 there's an x-intercept, and at -5 there's an x-intercept. Is this opening up or down?
It is going to be opening up.
Yeah, and now we can also find the y-intercept. Do you remember how to find the y-intercept? You said x as 0, okay?
X is 0.
So 3 times -4 times +5, so that's -12, so it's going to be -60. So that's the y-intercept, -60 down there. Now, you can also find some other things, actually. You remember the vertex form? We can take this into vertex form. H is going to be s plus t divided by 2. And k, again, like we did before, k is just f of h. We need to first find h, yeah? So s is just -4. T is the other x-intercept, 4 divided by 2, like that. Okay?
Yeah.
That's -1/2, that's -0.5. There we go. The vertex is at when x is -0.5. So this value right here, the x value is -0.5. And to find the y value, we'll just plug -0.5 into the equation. So 3 times -0.5 minus 4, -0.5 plus 5. I'm going to plug that in the calculator because that's efficient. So 3 times -4.5 times +4.5. And the vertex is at -60.75. So you see this point here? That is -0.5 and then -60.75, the vertex. And now once we have these values, we can rewrite this in the vertex form. Again, the a value stays as it is. It's just going to be 3x plus 0.5 squared because you have to flip it, right? This means the h value is -0.5 and the k value is as is. And there we go. We've converted this from factored form to the vertex form.
Wait, could we just go over the steps on how you got that again? I remember that you got the what's the first step?
First step, find s and t, the two x-intercepts.
Okay, we found that it's just the opposite of what's in the.
So once you have those, step 2, you find the h value by doing s plus 2 over 2. That means finding the midpoint of the two x-intercepts. And then step 3, once you have the h value, you just plug that into the equation as x, which gives you the k value.
Okay.
And once you have h and k, you just rewrite it in the vertex form. It's just ax minus h squared plus k. A is whatever the a was here. Yeah, a is always consistent among three forms. And h was minus 0.5. So if you plug that in here, you get a plus 0.5 squared, and k is just as is, minus 60.75.
And I don't know why I keep forgetting what h is, because you're telling me h is x, but isn't
H
there
is
x?
the x value of the vertex.
Is the x value of the vertex?
X is the function. X
Okay.
squared is the quadratic function. H is the x value of the vertex. And k is the y value of the vertex.
Okay, and then x is just the function itself.
Yeah, yeah. Well, when you
Oh.
open this, you're to get an x squared, so that's the function, the quadratic function.
Okay. We good with that.
All right, what's next? Or do you want me to?
We did factored form, vertex form, and general form.
Yeah.
So we're good with everything with the forms, I think. Wait, is there other forms like you can go from factored to something or something to factored?
Yeah, so let's talk about, this one's gonna be very useful, okay? We're gonna go from the general form to the factored form.
Yeah.
So let's say example, x squared minus 6x plus 8. So now compare this with ax squared plus bx plus c, okay? So convert this into factored form. We're gonna use a method called the man method, all right? I don't know if we did grade 11 math together. I think we did.
I think
Maybe.
we did do that.
Okay. Yeah, the man method, all right? So what does this mean? This means to convert this into factored form, we're looking for two numbers, okay? When you multiply them, you get a times c. So what would that be here?
A times c would be x times 8, so 8x.
No, a is 1, right? A, b, c's are the coefficients.
4, 5, so just 8.
8. So when you multiply those numbers, you get 8. When you add them, you get the b value in the middle. What's the b value? Minus 6. So what are the two numbers?
Then multiply them, so it's going to be negative 4 and negative 2.
Correct. Negative 4 and negative 2. So once you have the two numbers, right, you see the middle, you have a 6x. We're going to replace the minus 6x with minus 4x and minus 2x. So this is the next step once you found the numbers. So it's going to be x squared minus 4x minus 2x plus 8. We're going to split the 6x into 4x minus 2x. Now the next step, we're going to factor this two things at a time, okay? Two terms at a time. So let's look at the first two terms. What can we pull out? See, they both have something in common. We can pull something out.
We can pull out an x.
Yeah, what's left in the bracket?
You're going to have x minus 4.
Correct. Now let's look at the next two terms. What can we pull out?
You can pull out negative 2. Negative 2.
Yeah, and what's in the bracket?
It's going to be x plus 4.
Minus 4.
Minus.
Right, and these two brackets will always be the same as long as you got the numbers right. As long as they exist, these two brackets will always be the same. Now here, look at this. If you have xa minus 2a, yeah, if I pulled out an a, what am I left with in the bracket?
If you pull out the a, you have x minus 2.
All right, now notice this bracket is a, okay? So we're gonna pull the entire bracket out like that. What am I left with in the other bracket?
I remember this. Yeah, x minus 2 then.
Boom, there we go. Now we've gone from the standard form to the factored form. And your two
And
x-intercepts are 4 and 2.
And the a value remains the same.
Yes, so a value is still 1 here.
Okay, so that's general to factored. And then is there anything that changes if you put if the a value is a number? I forget. Like if it's not just 1.
So if it's 1, right? If it's 1, here's a shortcut. We did it the long way because usually a value is not going to be 1. If the a value is 1, you see we had our two numbers, -4 and -2. So in the factored form, it's simply going to be x minus 4, x minus 2 in one step.
Yeah.
For example, here's another question. Let's say we have x squared plus 6x plus 9. What are our two numbers? They multiply to 9, right? AC. And they add up to 6. What are our two numbers?
3 and 3.
3 and 3, exactly. So you can rewrite this in one step into the factor form. It's just going to be x plus 3 and x plus 3. So that's just x plus 3 whole squared.
Well, I was saying like if there's an a value that's not 1.
Yeah, then we do it this way. It's always going to work.
Oh, but like how did it change that? I don't know.
All right, let's do one with the a value is not 1. I'm gonna have to think a little bit. So let's say it multiplies to 16, or let's say it multiplies to -16, and it adds up to -8. All right, there we go. Actually, does that work? -16. 4, and let's say it adds up to 4 and 2, so multiplies to -8 and adds up to -6. Yeah, this should work. Or does it? Adds up to -2. It's kind of difficult to make the question.
Yeah.
All right, this one is gonna work, I think. Yeah. So what are the two numbers?
So multiplies to -8 is gonna be -4 and +2.
Yeah, -4 and +2. Now notice the a value is not 1, right? It's 2. But we're gonna do the same thing here. We're gonna replace the -2x with what?
With -4 and 2.
Yeah, -4x minus 2x, like that. Okay, or plus 2x, sorry. -4x plus 2x.
Mm.
And now again, we're gonna factor by grouping, two things at a time. So here, what can we pull out?
Oh, 2 x minus just 2x.
Yeah, and then what are you left with?
X minus 2.
Yeah, in the next bracket, what can we pull out?
2.
You're again left with x minus 2. Therefore, in factored form, that's going to be 2x plus 2 and x minus 2.
Okay, okay. So yeah, not much change is there.
No. Then you can find the x-intercepts by setting this equal to 0, right? This one, we know the x-intercept is going to be 2. What's going to be the x-intercept of this one?
4, 2.
So you see, what are we actually doing? We're flipping the things, but we're actually setting it equal to 0, right? That's how we're finding the x-intercept.
Oh, you're doing 2x plus 2 equals 0.
Yes.
So then you're gonna send the 2 over.
Yeah, so you're going to send the 2 over, it's going to be -2, and then you divide by the +2, so you get -1.
Okay. Okay, and did we cover everything that all the changes
Yeah, for quadratics we did, yes.
Okay, okay. We should be good then with that. Should we get into anything else in the review? Like,
Yeah, there's
there's a lot.
We need to talk about transformations.
Oh yeah, I forgot about that.
We'll just cover what we can cover. If you have the book, you can look at the example questions. Do you have the grade 12 book? You do, right?
Yeah.
Yeah, just start looking at the example questions. And if you don't understand, you can shoot me a message or we can pick it up. Because this is basically chapter 1 is the grade 11 review.
Okay, I think I could probably learn that because I just forgot.
All right, let me teach you transformations. This is very important. It's going to come back over and over in grade 12, okay? Any function f of x has this format. Don't worry about what they mean right now. F is a general function, whatever it is. Bracket open k, x minus d, bracket close, plus c. Example, let's do like a square root function. 3 is the a value, and f now is going to be our square root function. And let's say k is 4, and x is going to be x minus d. Let's say d is 5, and then plus c. That's an example of a square root function that has been transformed, okay?
Wait, why? I forgot. Why is there a square root?
That's just a transformed function. This is the parent function, y equals to square root of x, okay? Looks like this. Yeah?
Oh yeah.
This is just this function that's been transformed a little bit. So now let's talk about what AKDC do. And actually the AKDCs, they're consistent, okay? I'm just trying to show you what the F means. Let's do it for like a sine function. 3, now F becomes a sine, and then you have K, X minus D, plus C. Let's make the C a 6. Sine function, you can do that for a quadratic function 3. Now F is quadratic, and then we have 4. How would that look? 4 x minus 5 squared plus 6.
Where do you get the square from?
That's just the x squared, the parent function. I'm just showing you what it looks like, the transformations after you apply them. This is the absolute value function, like that. Okay, that's the general form. Again, F just means the general form. Yeah, F can be any function they throw at you. Now let's talk more about what A, K, D, and C mean. A, if it's positive plus B means it's positive, yeah? It does nothing. But if A is negative, it's a reflection on the x-axis. And A is the vertical stretch factor. If A is greater than 1, or the absolute value of A is greater than 1, it's a vertical stretch. And if the absolute value of A is less than 1, it's a vertical compression. We just need one function here. Let's just focus on the square root function. What's the value of A there?
The value of A is 3.
3. So is that, what does it do? Is there a reflection on the x-axis?
No.
No, right? Is it a vertical stretch or a vertical compression?
Greater than 1. So it's going to be vertical stretch.
Exactly. So the first transformation here, like a question will be this: what transformation brings you from the parent function y equals to square root of x to this transform function? Okay. So we know there's a vertical stretch by a factor of 3. By a factor of 3. Now the next one, let's move on to the next one. After A, you get the K, right?
Yeah, I forget, why is it stretch and like the other one's compression?
So if this was 1/3, it would be a vertical compression. Just think about it. You have this function, right? The square root function. If there's a 3 on the outside, that means you have 3 root x. So that means this has been vertically elongated.
Oh, and if it's
yeah, if it's like that, then it's been vertically compressed. If let's say this was 0.5 or something, then it's a vertical compression.
and what is this called again? A parabola?
This is called a square root function. We're doing transformations
Yeah.
in general, but this one applies to a square root function. But these ideas about AKDC applies to any function. We're just doing an example of a square root function because it's a good one. Okay. I'm gonna actually change this into -4, just to make things a little bit difficult for us. So you understood A?
We can do with anything.
So if you understood A, let's move on to the next one, K. Okay.
Okay.
All right, K, if it's positive, it does nothing. If it's negative, what does it do? If you remember from grade 11.
What is K again?
K is the horizontal stretch factor.
Horizontal stretch. Horizontal stretch.
So if it's K is negative, it's a reflection on the y-axis.
So it is reflecting right now.
Yeah, it is reflecting. So the next transformation here is a reflection on the y-axis because K is negative. Now this part is a little bit confusing. The stretch and compression for the K is the exact opposite as the A. Now, what do I mean by that? Here, look at this. If the absolute value of K is greater than 1, okay, you'd expect it to be a horizontal stretch, just like the A, but it's not. It's a horizontal compression. It's flipped. For the X values, it's flipped. So here, the absolute value of K is a 4. So this is a horizontal compression. And if it was, let's say 1/4 there, then it would have been a horizontal stretch.
But what is the opposite?
So this rule right here is the opposite of the rule for A. A, when it was greater than 1, it was a vertical stretch, but here K greater than 1 is a horizontal compression.
Horizontal compression. Now, why is that again? Like from a visual standpoint?
Because everything inside the function is the opposite. You see x minus 5, right? So
Yeah.
this kind of applies like the vertex form, right? X minus 5, the vertex is at positive 5. So everything inside the function, you have to flip it. So if minus 5, we added plus. So when we're multiplying, we do division. That's why it's a horizontal compression.
Oh, okay.
So,
And we covered everything in this, or we
no,
didn't
no,
cover
we're not done
the.
yet. We're getting there. So the next transformation here is a horizontal compression. Okay. Again, if you understand one of them, you're going to understand transformations for anything. Horizontal compression by a factor of 1/4. It's been horizontally compressed by a quarter.
Oh, I remember this.
Okay, did you understand K?
Okay, yeah, but I just know that if K is bigger than 1, it's gonna be horizontal compression, and you flip it over. It's like a reciprocal, right?
Yeah, exactly.
Okay, yeah, I understand that part.
Let's move on to D. So what's the D value right here?
D is 5.
Yeah, exactly. So if D is positive, it's a horizontal shift right or horizontal translation right.
Oh, 5 units right.
Mm.
Yeah.
And if D is negative, it goes left. Horizontally goes left.
But like in that point, it would be x plus 5 if it's an x.
Yeah, exactly. If it was x plus 5, it would be going left. Right now it's going right. So this one goes right by 5.
Okay.
Finally, C, again, very similar to D. If C is positive, then it goes up. If C is negative, then instead of going left, it goes down because C goes up, down. So here C is positive 6, so this means it's going up by 6 units.
Okay.
Okay, and to sketch this, let's do the point mapping rule. To sketch this, we're going to use the point mapping rule, which says this: any value, any point x, y on the original function becomes x over k plus d, ay plus c on the transform function. How does that work? Here, let me show you. So x, y on the original function, right? So we're gonna make a table of values. So this is gonna become x over minus 4 plus 5, 3y plus 6. I'm just plugging these values in there. This is called a point mapping rule. And we'll be using this rule for any function when we're doing transformations. Okay.
Mhm.
So let's give me some points on the parent function, y equals to square root of x.
So x over -4.
No. Give me some points on the parent function. So
Oh,
when
like
x is 0, y is 0, right? When x is 1, y is 1. When x is 4, y is 2.
that's 2, yeah, and then
9, 3, you can keep going 16, 4. Now, what we're going to do is we're going to plug this value of x in there as x. We're going to plug this value of y in there as y, and we're going to rinse and repeat until we get a few points.
so the first one 0, 0, right?
It is 0. 0 over 4 is 0 plus 5, so that's going to become 5.
5.
And this one 0 plus 6 is going to become 6. Okay.
Oh, okay.
The next one, 1 over 4 is minus 0.25 plus 5 is 4.75. And this is going to be 9. And then you keep going. Minus 1 plus 5 is 4. 6 plus 6 is 12. 9 over 4 is minus 2.25. Plus 5 is going to be 2.75. 3 times 3, 9 plus 6, 15. There we go.
Mhm.
And then you just sketch this on the grid, and then you'll have your final answer. So your original function looks like this. Now the transform function, the first point is 5, 6. The next one is 4.759. So 4.759 should be above 5.6. Let's say that's 5.6, 4.759, 4 and 12, 2.75 and 15, and there we go. It's gonna look something like this in green.
Okay. Yeah, that's pretty good for me. I just cause like I know we're really like it's actually 5 right now, but we're almost like done. Can you go over page 43? There's questions 3, 7, 9, 10, 11, 14, 16. So like any of those.
3 what, sorry? 343 you said?
Page 43, just 43.
43 of advanced functions?
Yeah. Because I think like they were doing a review and then this is like the new stuff apparently.
It's really not. Let me see. No, this from everything here is grade 11.
Page
This one is
43?
grade, yeah, 43, right? This page is grade 11. Here, I can just show you.
Apparently there's like a couple of tricky questions.
Yeah, probably tricky ones, but I don't know if it's new. Can do this really quickly.
13.
So they've given us a quadratic function, yeah. They want to find the
Actually,
inverse.
sorry, do you mind if we do like 14 just because it's not in the homework for me? Sorry about that.
Yeah, it's okay. So it says the inverse of this is this. All right, let's talk about inverses. So
Okay.
to find the inverse, right, you just swap the x and the y value. You see, this is the function they've given us. Let's find the inverse, which is y inverse. To find y inverse, x becomes y and y becomes x. Okay?
Okay.
So here, this is going to become x equals minus y plus 2. And you see this y in here?
Mhm.
This new y is y inverse. So you need to solve for this new y. So how do you solve this equation or isolate for y?
You can do square root of x to get rid of it.
No, square. You want to get rid of this, so you're going to square both sides.
Oh, square.
So you get x squared equals y plus 2 because negative anything squared is positive.
And then you can subtract 2 from the other side.
Yeah. So you get y is equals to x squared minus 2. Okay,
And then that's all.
that's all. That's the inverse. But here, notice it says the inverse of y equals this is this. Yeah,
X squared minus.
that's what we got. But it's a little bit tricky because the inverse of any quadratic, right? If you just solve for this, let's say y equals x squared. If you want to find the inverse, you swap the x and the y, and you see this is the new y.
Mhm.
You want to solve for this, you square root both sides, right? But here, at this level, whenever you're square rooting, you have to add a plus minus.
Okay.
So the inverse of y equals this would have been plus minus x plus 2, not just minus x plus 2. That's why this statement is not true, because it's missing the other half.
And why do we always have plus minus?
Because think about it. What's the square root of 4? It's 2, but it's also minus 2, because minus 2 squared is 4. So the square root of any number is plus minus.
Also, the square root of anything has to be plus minus?
Yes.
Oh. Wait, could you have just said that from the start, though, that you have to have a plus?
Sorry?
Could you have just said that from the start? Like, you just have to add a plus?
Or you have to add a minus, because usually you would get the plus 1 by itself, right? Square root of 25 is 5. That's what the calculator gives you, but we know it's plus minus 5. So we need to add the minus.
Okay. Okay, so could we do 16? I think we have like 5 minutes.
All right, there's a C. C is for communication, okay? Let's do this one. Let's say you have this function, y equals 2x plus 3, and the question's asking you, what's the inverse of this function?
So I make
No, you don't have to do it like that. That's for like complex problems. This is a linear one, right? This one's is a little bit easier. So what did we do to this function first?
you make the y the x and x y.
We could do that. That's doing it algebraically, but this is not what the question's asking you, okay?
Wow.
So what did we do to this x first? We multiplied it by a 2, yeah?
Yeah.
And then we added a 3, right?
Yeah.
The inverse function is going to be the same thing in the opposite order. What do I mean by that? So 2x, instead of first multiplying it by a 2, okay, you have to subtract 3. You do the opposite. The signs flip as well. The order flips. The signs also flip. So the inverse of this is going to be x minus 3, and times 2 becomes over 2, and there we go. That's the answer. And we can prove this by doing it algebraically. So this is going to become x equals y, or 2y plus 3, right? How do we solve this equation for y?
How solve this question for y?
Yeah. We
Let's
subtract
do
3
the
and divide
opposite.
by 2, right? We subtract 3 and divide by 2. Notice that's what we have here. So this is the shortcut way of finding the inverse. And that's what this question is talking about. He's correct.
Wait, but how come the inverse is the same as the y?
This is the new y, so this is the y inverse, actually, technically. This, because once you flip it, right, that becomes the new y. That's y inverse.
Oh, okay.
Like, for example, we can do like a bunch of these ones. So we had 9x plus 8, right? What will be the inverse in one step?
You're gonna do minus x and divided by 9? Or
Yeah.
minus 8, I mean?
Yeah, so you do minus 8 and divide by 9, right? There we go. Because the order flips, the signs also flip. So here we multiplied by 9, added 8. Now we're going to subtract 8 first, and then we're going to divide by 9. And there we go. That's the inverse.
Okay. So I think that's good for the advanced homework. Just one question for calculus that I was tripping on was question 9. I don't know if you can go to the textbook for that.
Page what, sorry?
On calculus, the textbook.
Yeah.
It page 307, number 9. Number 9 and 10 was tricky.
No, we did this yesterday though. We'll do it again. It's okay.
We did this yesterday?
I believe we did.
Wait, no. I'm definitely thinking of something else.
9, right? This is 9.
Wait a minute. I'm looking at 307.
Oh, 307. Well, okay, no, I was looking at 309.
Yeah, 307, number 9. Oh yeah, that one. 3 and 10 were crazy.
So you want to do number 9?
Yeah, we could do 9.
So it says express x and y in terms of a and b. Alrighty, so this is just an elimination question. Let's isolate for either x or y from this vector, okay? So we have 2x, again, I don't really care about the arrows. So 2x plus 3y equals a. Let's solve for x.
Okay.
So what do? We subtract 3y, right? And then what do?
Then you're going to divide by 2?
Yeah, exactly. So this is x, okay? Now we're going to plug this as x in there, in the other equation.
Wait, are you gonna solve for b first?
Oh, this is b, this is not a, actually. Express x and y in terms of a and b. No, it's fine. You can, x is going to be in terms of both a and b. Yeah, that's fine. We're good.
Oh, no, that's right. I'm saying like, are we gonna get like the b for 6b equals?
Yeah, so we're just gonna, you see this x, we're gonna plug this in there as x, okay? This thing in there as x. Let's try that.
Oh, why do we do that though?
To eliminate one of the variables.
Okay.
So there we will no longer have an x. Right here, look at this. So now I'm gonna replace this x with this, what x is from the first equation. Then you get minus a minus 3y over 2, right? Plus 5y, okay, equals 6b.
Yeah.
And there we go. We have y kind of already. Actually, we need to open this bracket. So let's open that bracket. We get minus a plus 3y over 2 plus 5y equals 6b. Yeah? I just open this. And let's find the common denominator here. It's going to be minus a plus 3y over 2 plus 10y over 2. Yeah? Common denominator. I changed 5 into 10 over 2 so I can add them. Equals, and again, you can also find the common denominator there, 12b over 2.
Do you have to do common denominator for every single thing?
No, you don't, but you could, because once you have a common denominator everywhere, they all cancel out.
True. Oh, or you guys multiply everything by 2.
Yeah, that's exactly what we're doing here. Yeah, to get the 12b. And then let's write this. So we got minus a plus 13y equals 12b. I'm going to add a on both sides. 13y equals a plus 12b. And therefore, y is going to be a plus 12b over 13. And there we go. We have expressed y in terms of a and b. Now we're going to find x as well in terms of a and b by replacing this y with this. It's going to get a little messy here. A minus 3, so x is going to be a minus 3 times a plus 12b. Actually, do we even have to simplify this? I don't know if we even have to simplify this because we've answered the question technically. X in terms of a and b.
I don't know if that was the answer.
I'll look for what the answer is for y. Then we can just simplify this. I mean, if that's not the answer.
For y. Okay, let me check. 307. For y,
Yeah, this is the answer, right? A over 13, a plus 12b over 13. Yeah, there we go. It's right here, buddy.
no. Y equals 1 over. Oh, wait, I'm not on the Zoom. Hold on. Yeah.
It's the same thing as this one, right? They just split apart the denominator. See, this and this is the exact same thing. You can just split the a over 13 plus 12 over b over 13, and that means the same thing.
Okay, so and then the x is the same?
Well, x is yeah, this is right, but we can simplify it. I mean, if you want the final answer, they simplified it, right? Yeah, they did simplify it. So again, it's just algebra. It's not hard. So to simplify this, we just open this bracket. We get a minus 3a minus 36b over 13 all over 2. Okay, and all over 2 divided by 2 just means you're so divided by 2 means you're multiplying by 1 over 2. Okay. Then we can take the common denominators, 13a minus 3a minus 36b all over 13 times 1 over 2. So what does this give you? This gives you 16a over 13, or 16a over 26 minus 36b over 26. And that's going to be 8a over 13 minus, divided by 2, 18b over 13. I think that's what they have as well. 18, 13, 5, 13. So this should have been a 5. Yeah, it should have been, my bad, because 13 minus 3 is a 10, not 16. Yeah, 10a over 26, and this becomes 5a over 13. And there we go. That's what x is, final answer, which is basically the simplified version of this.
Okay. Let me just take a picture of that, and we're good. And how long does it usually take to upload to YouTube?
Like No, yesterday I was late.
Oh,
Takes 30 minutes,
you
I
usually
think, for it
talk
to like process and everything, like 30 odd minutes.
30 minutes.
Mhm.
Thank you so much for that. If you just upload it right now, just because I'm like 4 classes behind.
Sure,
That would
I'll do
be
that.
good. And yeah, other than that, I think we're good.